Okay. Good evening, good afternoon, everyone. So sorry once more. I think we would need to, anyone that is not speaking, please kindly mute your mic. Okay, more people are joining. I think we can get started already. Varini, are you ready, please? Okay, please. Thank you so much.
Okay. So today we'll go over order of operations in LCM or GCF. But before we start, did anyone have any questions on the worksheet I gave you? Okay, so I'm gonna take that as no questions. So we'll move on. Okay, so what are the order of operations? Are you guys familiar with the order of operations? You can let me know in the chat. Yeah, the worksheet was posted on the Google Classroom. Okay. So the order of operations is parentheses, exponents, multiply, divide, addition, and subtraction. So can you guys type this privately to me and tell me what you know? I'll give you guys 2 minutes to answer these sort of questions. And then just let me know in the chat. Okay, does anyone want to tell me what parentheses look like? Like you can just type it in the chat. Okay. So parentheses, oh, oops. Yeah. So parentheses look like that. They're basically these open and closed things. And this will go around numbers, and when we do some practice problems, you'll see how they sort of play into how we're supposed to analyze or like simplify expressions. And then 8 squared is 64, and then 12 times 6 is, yeah, whoever raised their hand. Do you have a question? Amina? If you're raising your hand, could you like unmute? Oh, you can't hear? Can others hear me?
No.
No.
Yes.
Oh, you can hear me?
Yes. Yes, please, we can hear you.
Oh, okay. Thank you for letting me know.
Okay.
Does anyone else have, okay. Okay, does anyone else have any questions or anything?
Yeah.
Yeah? What's your question?
Please. Question. A question.
Okay.
Question.
Yeah?
Please, when are we going to get our work scores?
Your work scores? Oh, I've been slowly
Yes.
going through them. So like by the end of like after class today, I'll make sure to get everyone's scores done.
Okay, madam.
Yeah.
Please, can you can you go over the components of the PEMDAS? Please, I wasn't around that time. The
Oh
internet.
yeah, we can go back. Okay. So the operations for PEMDAS, it goes like this will go first. So this you'll calculate first and
Please,
then
the parentheses. I wasn't in class, and so please, may you explain it again?
yeah. So first are parentheses, which look like this. And when you're given anything in parentheses, let's say like 1 plus 3, this will be the first thing you evaluate in the expression. Next is exponents. So exponents are like 3 squared or 3 cubed or something like that. And this is what you'll do after. So if you have an expression like 3 squared plus 1 plus 3, you do the 1 plus 3 first, so you'd get 4 plus 3 squared, and then you do the 3 squared, which will give you 9 plus 4, and then you get 13. And then the thing with multiplication and division is that these can happen interchangeably. It's just whatever you see first. So if you have like 3 times 2 divide by 6, you'd first do 3 times 2 because you move left to right. So you'd get 6
Madam.
divided by 6, which equals 1. And then if you were given an expression like 3 divided by 6 times 2, you'd first do 3 divided by 6, which would give you 1/2, times 2, which would give you 1. And then same thing applies for addition and subtraction. It's just basically whatever you see first, you do first. Does that make sense to everyone?
Yeah.
Yes, please.
Huh?
Yeah.
Yes?
Yes, please.
Yes, please.
Okay.
Yes.
Then we'll move on. Okay, so we'll go back to this. I'll give you guys 2 minutes to answer what this is. I'll like the questions on the screen, and make sure you private message me, and I'll let you know the answers after 2 minutes so you can verify. Okay?
Okay. Madam.
Yeah? Oh, okay. Does everyone understand what they're supposed to do? Because I've only received answers from 2 students.
Yes.
Okay. I'll give you guys a little more time to maybe like answer the questions, and then I can go over the solutions after. Okay, I'll go over the solutions now. So, okay, so here are the solutions. So, this is what the parentheses look like. So it's just like open and close brackets. 8 squared is 64. So that's just like something you should try and memorize. But yeah, and then 12 times 6, if you do 12 times 6 like this, 6 times 2 is 2, carry over the 1, and 6 times 1 is 6, plus 1 is 72. And then 132 divided by 4. 4 goes into 13 3 times, so minus 12. You get 12 again, which is 3, so then you do minus 12, and you get 0. So the answer is 33. And then for number 5, it'd be 1083 plus 366, which gives me 9, 4, carry over the 1, 4, and 1. And then 968 minus 254. 8 minus 4 is 4, 6 minus 5 is 1, 9 minus 2 is 7, so you get 714. Does everyone understand how I got all the answers? Or,
Yes.
Yes, please.
Yes,
okay,
please.
we can move on then. For some reason, my computer is being a little weird. Give me 1 second. Okay. So, we're just gonna go over the steps for PEMDAS again. So, you have to remember this, so it will kind of help you with the order of operations. And one way to remember it is, please excuse my dear Aunt Sally. So you can use that to kind of remember PEMDAS. Parentheses are the first thing we do when we evaluate things and expressions, and remember it just be like something within these brackets. Exponents are the next thing we evaluate, so it'd be something squared, something cubed, anything with a power. And multiply and division, these are done together. You can multiply and divide working from left to right. That's very important. Addition and subtraction are also done together, and you can add and subtract again, working left to right. So if some of this doesn't make sense to you, we'll go over some practice problems that will maybe help clear up some confusion, especially with like the multiplication, division, and then the addition and subtraction. But so far, does anyone have any questions? Everyone gets it? I'll give you guys some time to maybe copy it down if you need to.
Yes.
Okay. Okay, is everyone good to move on?
Not yet.
Okay, I'll give you some more time. Okay, how about now? Is everyone good to move on? Or
Almost.
okay.
Yes.
Okay, we'll give everyone else like a minute and then we'll move on. Okay, is everyone good to move on?
Yes, please.
Okay.
Yes.
So, one thing I just want to like point out, that someone brought up is the idea of board mass. This and PEMDAS are like literally the same. So if you've learned board mass before, it's like the same as PEMDAS. So you don't have to worry about learning PEMDAS. You can just use board mass. Yeah. Okay. So, how do you think we should, I guess, compute this expression so that we could get 16? Does anyone have an idea of what the first step should be?
Please, the question again.
Yeah. So we're given this expression, and so I just want to see how we can simplify or expand this part, like parenthesis 5 plus 3 close parenthesis times 2 gets us 16. So what would the first step be to like move towards the answer? Does anyone have an idea? Think like PEMDAS, what is the first thing in PEMDAS? Or like board mass, what's the first thing in board mass?
We should add the values in the parentheses first.
Yeah, that's correct. So we'll do 5 plus 3. So we'll get 8 times 2 equals 16. And what is 8 times 2?
16.
Yeah, so then we get 16 equals 16. Yeah?
Please, I can't hear you.
Can anyone else hear me? Does everyone else?
Yes, please.
Is it like clear?
Madam.
Yeah?
Yes, please.
Okay. Okay. We can keep moving on that, I guess. How about the second expression?
Please, madam, you do 3 times 2 equaling 6. Then you add the 5 plus 3 times 2. So 5 plus 6 equals 11.
Yeah, that's correct. Good job. So I think you guys got this. So we'll move on. Okay. Why don't you guys try doing this one by yourself? And
Please,
then,
should we private chat it to you?
yeah, we should private chat me the answer.
Okay.
And then I guess also kind of explain the steps you took.
Please affirm my answer.
Yeah. I'm replying to everyone. Don't worry. Okay, so I'll give you guys 1 more minute to answer, and then we will go over the solution.
Is it okay if I change my answer?
Yeah, you all can keep submitting your answers.
Thank you.
Uh-huh. Okay, so I guess we'll go over the answer now. Yeah, you all did very well on this, so good job. Okay. So first, let's take a look at parentheses. So we see that there are parentheses here between that encompass 9 and 3, so here and here. So we should evaluate what's in between here first, and we get the answer is 27. So now our expression becomes 27 plus 5 minus 10. So if we work left to right, we see the addition first. So we'll do 27 plus 5, which gives us 32 minus 10. And then we get 32 minus 10, which will give us 22. So the answer is 22. Does everyone get that? Everyone good?
Yes, please.
Yes, please.
Please go with him.
Good.
But only sending.
Huh? Did someone say they didn't understand? Or does everyone understand? Okay. I'm gonna move on. If there's any confusion, please let me know in the chat. That way I can see it. Okay. Here's another problem. You guys can try this one out as well. And then just let me know your answer in the chat. And make sure you private message me with like how you did it as well, like the steps you took. So I'll give you guys a couple of minutes to attempt this, and then we'll go over the solution again together. And if anyone who gets the right answer wants to explain how they did it, also please let me know.
Please, may I explain the cube one more time? My laptop went away for a few minutes.
Sorry, can you say that one more time?
Please, I was out for a few minutes. Please, can you explain the 4 cube?
Oh, okay. So 4 cubed is an exponent. So instead of writing 4 cubed like this, you can write 4 cubed equals 4 times 4 times 4. So you can expand it like that. So your expression actually looks like 4 times 4 times 4 times 6 plus 8 divided by 1. So, yeah.
Okay, please, I've gotten it.
Yeah.
48. 48.
26.
Oh, can you message me, please?
Okay.
Yeah. Thank you. Please private message me. Yeah, everyone is doing very well. Just be careful when computing 4 cubed. It's not addition.
Madam, please, Madam Varini, this is say divided by 1. What does it mean in general?
So, in general, when you say divide by 1, it means like it should just give you the same answer. So basically divide by 1 does not do anything to your answer, but just make sure you compute this in the correct order so that when you do divide by 1, it's like the right answer. I don't know if that made sense.
If it makes sense, I've sent my answer.
Yeah. Okay, I'll get to it. Your answer is not going to be a remainder. Or your answer will not have a remainder. When you divide by 1, so like if I do 4 divide by 1, this will just give me 1.
I didn't add a remainder to my work.
Huh? Sorry?
I didn't add a remainder to my work.
There should be no remainder.
So I didn't add one to my work.
That's okay.
Please, my name is the one with AS.
Yeah.
Please, may I explain how I got my answer?
Yeah. Hold on. Let me check your answer really quickly. Okay. Hold on.
Should I explain it?
Sure. Yeah. Go ahead on how you explained it.
Hello, Varini. Sorry, please hold on. I don't know. Has everyone submitted their answers? Do you feel it's okay for her to go ahead to share how she got her answers?
Yeah, I think a lot of people have submitted their answers.
Okay, please.
Yeah.
Okay. Mama said she doesn't understand. That's why.
Oh, okay. So we'll let them go over
Okay.
the answer, and if they have any problems understanding, I can go over it after as well. Okay. Give me 1 second before you explain. Yeah.
Okay.
Thank you.
And I'm just here getting a lot of I don't understand.
You don't understand how to do it, or?
No, I said plenty people are sending that I don't understand.
Okay, so do you want me to go over it?
Yes, just to make sure my answer is correct before I say how I got it.
Okay, yeah, I can do that. Okay, I'm just gonna go over the answer now. I'm sorry if I didn't get to you. Please verify your work. Okay. So this is kind of how you do it. So first you do what's in the parentheses, so that gives you 14, because 8 plus 6 is 14. Then you're going to compute 4 cubed. So I know 4 cubed was a little bit hard for everyone, so I'll go over how to compute that. So you can do 4 cubed, you basically split it into 4 times 4 times 4. And so when you simplify 4 times 4 times 4, you get 16 times 4.
11.
And when you do 16 times 4, you get 4, you carry over the 2, and you get 64. So that's how you end up with 4 cubed is 64. Whenever you see an exponent, you can always break it up into basically like the number times itself, how many exponents there are. So if it was 4 cubed, it would just be 4 times 4 times 4. So it'd be like 4 times 3 of itself. I'm not sure if that made sense. But like if you have 6 squared, it's going to be 6 times 6. You have 2 6's with the square. If it's like 7 cubed, you will have 3 7's multiplied by each other. Oops.
Please, may I say my how I got mine?
Yeah. Okay, I think that was the confusing part. Do
Please
you want to
first.
continue? Do you want to continue with how you did it?
Yes, please.
Yeah, go ahead.
So I'm not sure if it's right or wrong. Please first, I got my 4 cube, which I thought meant 4 times 4 times 4.
Yeah, it is 4 times 4 times 4. But when you multiply all the 4's together, you get 64. Does that make sense? So when you have 4 times 4 times 4,
64.
you can simplify that into 16 times 4. Because we know that 4 times 4 is 16, right?
Yes.
Okay, so then we get 16 times 4. So now in order to get what 4 cubed is, we need to do 16 times 4. So we do multiplication here. So we get 6 times 4 gives us 24. So we have 4 and then the carryover of 2. And then we have 1 times 4 plus 2, which gives us 64. Good?
Yeah, please.
Okay, you can continue with what you were doing.
So I want
Yeah.
to change my answer.
Okay, that's okay.
Okay, so please, my new answer, the 4 cube will now be 6. The 4 cube will now turn to 64. So you do 64 times 14.
Yeah, that's
So
correct.
then you do 64 times 14.
Yeah.
My connection is a bit unstable.
That's okay. There's one more step left. Do you want to go over that one step?
I'm solving it here.
Okay, take your time.
10, 11, 12, 13, and 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 48. 1, 2, 3, 4, 5, 6. 'Cause I've gotten my answer now.
Okay, yeah, go ahead.
So it's a first.
Sorry, can you say that again? Hello? I'm not sure what happened. Yeah, okay. So I'll just go through the rest of the solution. So then you do 64 times 14, which gives you 896 when you do it. And then anything divided by 1 will just give you whatever you are dividing. So 896 divided by 1 will give you 896. And because there's no addition or no subtraction, your answer is 896. Did everyone understand? Are there any questions? No questions? Okay, so we'll move on. So the next topic we'll go over is called LCM and GCF. So LCM stands for least common multiple, and GCF stands for greatest common factor. So LCM is basically like what multiple they have in common and like what's the smallest multiple, and GCF is like what's the greatest factor they have in common. So today we'll be learning the cake or like ladder method, and you can do LCM and GCF at the same time using this method. So that's why we're going to go over it. So here we go. So here's an explanation on the right, or like an example problem on the right. So we have numbers 24 and 32. So since 2 is a factor of both of those numbers, we can take the 2 out, of them, and we are left with 12 and 16. So we do 24 divided by 2, which will give us 12, and 32 divided by 2, which would give us 16. And then let's look for another factor. So another factor could be 2. So let's say we take out 2 again. So if we take out 2, we're going to divide by 2 over here, divide by 2, and we're going to get 6, and we're going to get 8. Then we're going to divide again, and we're going to take out another 2, so we're going to get 6 divided by 2 and 8 divided by 2, which gives us 3 and 4, which no longer have anything in common. So the way this method works is that you're just going to keep dividing by factors until you reach a point where you can't anymore. So to get the greatest common factor, you're going to multiply all the numbers on the left, so that's all of these 2's. So what that's telling us is that the greatest common factor, the GCF, is equal to 2 times 2 times 2, which gives us 8. And then for the LCM, we multiply all the numbers on the left and at the bottom. So our LCM is going to be equal to 2 times 2 times 2 times 3 times 4, which gives us 8 times 12, or 96. Does everyone get this?
Yes, please.
Okay. If you have a question, please let me know in the chat and I can answer it. Okay. So I'm gonna clear everything. Is everyone okay with me clearing it? Okay. So why don't you guys try this problem? So find the GCF and LCM of 14 and 35, and then let me know what your answers are, and then I'll go over the solution after. Okay? So make sure you private message me, and also show me like kind of the steps you took, so that way I can help you like locate your mistake if you made a mistake. So. Please don't draw on the board. If you get the right answer and you want to share, you can then draw on the board. But before that, please don't draw. And let the other students kind of figure it out. And also let me know if you want to like share the answer you got. Like if it's right, if your answer is right. Please let me know if you want to share how you got it. So I'll give you guys like 5 minutes to do this and then let me know. Yeah.
Madam
Yeah.
Varini, please, my internet went off. So when you were teaching the cake method, the GCF and the LCM, I wasn't there.
Okay. Why don't we let others? Oh, please don't draw on the board.
I wasn't drawing on the board.
Oh, you're not the problem. You're not the. Don't worry about that. So I can, once we go over the solution to this, I can kind of explain how it works. Is that okay?
Yes, please.
Okay. Whoever's drawing on the board, please don't draw. Okay. Okay. So we're gonna have a student explain. So whenever you're ready, you can start explaining.
Okay, I'll explain it. Okay. 14 and 35. There are no other numbers, or there are no other values that can enter 14 and 35 apart from 7. So 7 will enter 14 2 times and enter 35 5 times. And that will make 7 the GCF and the LCM 7 times 2 times 5, which is 70.
So can you explain what you did once more so I can write it down?
Okay. I said 14 and 35. 7 will enter 14 2 times and enter 35 5 times. And there's no any number that can enter 2 and 5. So that will make 7 automatically the GCF. And the LCM 7 times 2 times 5.
Okay.
Which is 70.
Okay. So basically a lot of yeah, whoever raised their hand, do you have a question? Yeah. Oh, I can't hear you.
Hello, please. My daughter is trying to log in using a laptop, but they are not trying to let her in. So I don't know if they can allow her in, because my phone, I'm making use of my phone, and calls comes in and cuts the network, please.
Hello, ma. We are at the. No, we don't see. We've been admitting people inside. You just to confirm whether she's with the right link. Because nobody's in the waiting room.
But is it okay? Can you just send the link again in the WhatsApp group? So let me try again, because that's what I use for my phone.
Okay,
But it's not
please.
working in my laptop.
Okay.
In the Chromebook she's using. Thank you.
Yeah, who's raising their hand?
And please, my internet is very slow, so the computer keeps going on and off. Please, so can you explain GCF? Please, just one more time.
Yeah. So the way this works is, I think a lot of you understood the method, but not really how to get the answer. So what you're gonna do is that for the cake method, what you're gonna do is you're gonna try and find the greatest thing you can pull out of both of the numbers. So if we see 14 and 35, the greatest number we can sort of pull out, or like a number we can pull out, is 7, because 7 is a multiple of both of them. So then what we're going to do is that once we take 7 out over here, we will divide these both by 7 to get 2 and 5. Is that part clear?
A little, a little.
Okay. And so then to get the GCF, is we're going to multiply all of the things on the left-hand side, just the left-hand side. So looking here, we can see that only 7 is on the left-hand side. And between 2 and 5, you can only pull out 1. So 7 times 1 will give us 7, which is the GCF. And then to get the LCM, we need to do 7, so the things on the left, times the numbers at the bottom. So if we have a total of 7 on the left and 2 times 5 on the bottom, our LCM will be 7 times 2 times 5, which will give us 70. Does that make sense?
Yes, please.
No, please, can you explain it again?
Madam,
Okay.
please, are you saying, Madam Varini, are you saying that 7 times 2 is 14? So if we do 14 times 5, our answer will become 70.
You don't do 14 times 5. You do 7 times 5. So it'd be 7 times 2 to get 14, and then 7 times 5 to get 35.
It's not making sense a bit.
Okay, let me go back a slide and I can explain it there, because I think that might be easier to understand. Okay, so we'll go back here. Oops. Sorry. Okay, so let's take a look at this example, because I think this one is a better example. So we have the numbers 24 and 32 here. So the one factor we can take out of them, or like something we can multiply by something else to get these numbers, is 2. So if we do, we can pull out 2 from it. Does that part make sense to everyone?
Yes, please.
Okay. So then, in order to get the next layer of our cake, we need to divide 24 by 2 and 32 by 2, because that's the factor we pulled out. So when we do
So,
that,
Madam,
yeah?
24 divided by 2 is 12.
Yeah.
Then for 32, that would be 16.
Yeah. So that goes in the next layer of the cake. That's one layer down. Okay, so now we're going to do the same thing again until we get numbers that we can't take out anything anymore of. So like if we keep going, we can still take out 2 again from 12 and 16. So if we take out 2, we're going to divide by 2 again, and we're going to get 6 and 8. Then we can still pull out a 2 again, because they're both equal.
So,
So
how do you say it? Say, you can divide 6 by 3 and 8 by 4.
oh, so
Then
you just want to
here,
divide.
you.
Sorry.
Madam
You just
Varini,
want to
please,
divide by.
Madam
What?
Varini, please, the 4 over here. Can't you use a 2 to divide it to get another 2?
So what you're going to do is you're going to take 6 and you're going to divide it by the factor you pulled out. So if I take 2 out, that's the number I'm going to divide by. So I'm going to get 6 divided by 2, which gives me 3, and then 8 divided by 2, which gives me 4.
Got it.
Okay, does that make sense to everyone? Because I know some other people had confusion as well.
Yes, please, it makes sense.
Okay. Okay, so now we'll go over another problem because I think that's what other people want. So, yeah, if you guys have more questions, we can go over that as well. Okay, this one's a little bit trickier because there's 3 numbers, but it works exactly the same. So I'll let you guys try it and then we can go over the solution. If you have any questions also, please let me know and I'll answer it.
Sure.
And please make sure you private message me the answer with the steps you took. So that way if you have a problem, I can help you solve it.
Thank you.
Yeah. Yes, whoever raised their hand.
Can you please go back to the cake slide?
Yeah. Is this the slide you wanted?
Yes, please.
Okay.
Please, while she's done with the cake slide, please can you send it back to the 14 and 35 method?
The 14 and 35 one?
Yes,
Wait,
please.
I'll
When
put
she's
the
done with,
problem up there.
please, when she's done with the cake method.
Yeah. I'll put the problem up here. So the problem was to find. Okay, so I put the problem at the top of the screen. So if you guys need the problem, it's there. And then here's kind of like the steps you can take to try and solve the problem. So yeah.
Please, is she done with the cake method?
Amina, are
The
you?
previous.
Yeah.
Please, is she?
Whoever asked for the slide, are you done with it, or do you still need it?
Should you carry on if there's a remainder?
I can't hear you very clearly. Could you repeat it?
Stop if there's a remainder.
I can't understand you. Could you type it out, and I can respond there?
Please, can you put it on the previous question?
On the previous question, so the one, okay, I'll type the previous question here.
Please with the answer, like the previous question with the answer.
Okay, yeah, I can do that. Okay. I'm going to go to the next slide. Okay. Here's the answer to the previous question.
Thank you.
Okay. Can
I'm
I?
about to,
Yeah. Okay, I'm gonna go to the next slide. Is that okay? Okay. Here's the problem. So I'll give you guys a couple more minutes to solve it, and then yeah.
I've sent my answer.
Okay.
Please, can I give my please, was my answer correct?
I think you only sent one number, but the question is asking for two numbers. So could you just specify, like, could you like find both of the numbers and then just specify what answer corresponds with what number? Okay.
Please, 300 specifies for the LCM. Then for the GFC, 3 specifies for GFC.
Okay, I think your GCF is correct, but your LCM is slightly off.
So should
just
I solve the LCM again?
Yeah, but your GCF is correct.
Okay.
Okay, it seems like everyone is struggling with the LCM, so I'll give like another minute, but I will give you a hint. So I'll work out the cake method for you, and then I'll let you find the GCF and LCM. So we'll start off with our numbers 12, 15, and 18, and we can pull out a factor of 3 from all of them. So we're left with 4, 5, and 6, which we can't really pull out anything from. So our LCM is what, and our GCF is what? I think this one's a little bit tricky.
Almost got the answer. One, two, three, 4, 5. Please, my LCM answer is 360. Is that correct?
I think there's a slight with this problem. We'll go over the solution, but I think everyone understood the GCF, but not the LCM. So you guys a little bit. Okay. So go clear my screen. Okay. So let's look at this. We notice that our GCF is only 3, right? Because, or actually, let's walk through the method. So we factor out a 3. I think everyone got that part because everyone got the GCF. So now we're left at 4, 5, and 6. Well, let's look at 12 and 18. The common factor between 12 and 18 is 6. And so if we stop here and like not take out a 2, then we'll be double counting 2 2s. We'll be double counting 2s. I don't know if that makes sense, because when you do 5...
No, please, I don't understand the...
You don't understand the LCM?
I don't understand what you meant by if you stop here.
Okay, yeah, I can do this again. So let's see. Okay, I think everyone understood this first step. This first step was very clear for everyone, I believe. So let's continue after that step. So once you factor out 3 from everywhere, you're left with 4, 5, and 6, right? So let's pretend we stopped it here. So let's pretend this was the last step we went through. Last step. And so that would mean our LCM would be 3 times 4 times 5 times 6. But that doesn't look the same as 180. So let's figure out why. So if we look at 4 and 6, 4 and 6 still have a common factor of 2. And by multiplying 3 times 4 times 5 times 6, we are double counting that 2 as like an additional 2. Does that make sense to everyone?
No.
Okay.
No.
So
I still don't get it.
okay. So basically, when we're looking at this, let's like break this up. So let's find the greatest common factor, or sorry, the LCM between 12 and 15, and between 12 and 18, and between 15 and 18. Okay? So let's break it up into 3 different sets. So if we're looking at 12 and 15, if we factor out a 3, then we're left with 4 and 5. But 4 and 5 have nothing in common. So the LCM of 12 and 15 is going to be 3 times 4 times 5, which will give us 12 times 5 or 60. Okay? So now let's look at 12 and 18. So we can factor out, in 12 and 18, we can actually factor out a number greater than 3. We can factor out 6. So we're left with 2 times 3. So our LCM will be 6 times 2 times 3, or 36. And then with 15 and 18, we can factor out a 3, so we get 5 and 6. So our LCM here will be 30 times 3, or 90. Okay, so now we've got 3 numbers, right? So let's see what the LCM is between those 3 numbers. So we have 60, 90, and 36. Let's see what the LCM is between all of them. So what is the number we can take out from 60, 90, and 36?
6.
Yeah, we can try taking out 6.
6.
Okay, so 60 divided by 6 is 10. 90 divided by 6 is 15. And 36 divided by 6 is 6. Is there another number we can take out? No, right?
Yes.
Yes.
Yeah, what is it?
I think yes.
Okay, yeah, you're kind of right. There is one more number we can take out, and that's between 15 and 6.
Okay.
When we look at this, let's think about it. So, ignoring the cake method, if we're given 60, 90, and 36, what do you think the most common factor would be? So let's just start by multiplying 60 by 1. If we multiply 60 by 1, we get 60. Can 90 and 36 ever reach 60? You multiply it by anything? No, right? So let's try another number. Let's do 60 times 2, which gives us 120. Can we reach 120 using any other number? Well, for 90, we can't. 90 times nothing gives us 120. But 36 times what might give us 120? Would 36 times anything give us 120?
No.
Yeah, so this one doesn't work either. So now let's look at 60 times 3. 60 times 3 is 180. Can 90 times anything give us 180?
Yes.
Yeah.
Yeah, what is it? 90, right? So we got a number there. How about 36? Does 36 times anything give us 180? Yeah, it does. 36 times 5 should give us 180. So look, we found our least common multiple between those numbers, and that's 180, right?
Yes.
So if the cake method is not working, like you get kind of stuck right here, you can always just try and use like process of elimination and like work through what the number might be.
Okay.
So wait, let's go back to this problem now. Okay, so we've reached this point where it's 4, 5, and 6, right? We're
Yes.
looking at the LCM. We want to multiply, like,
Yes.
we want to multiply all the individual factors of the, like, how do I put this? We want to multiply all the unique factors that are not common between the numbers. So if we're looking at 12, 15, and 18, there's a 3 here, right? So the common ones, we only want to multiply by 1.
Yes.
So
Yes.
our sum is going to be 3 times. Okay, let's move on to the next set of numbers. When looking at the next set of numbers, on 4 and 6, they still share a common number. And if we were to multiply by 4, 5, and 6, we would be double counting that 2. So if we were to prime factorize 4, 5, and 6, we'd see that 4 is 2 times 2, 5 is 5 times 2, and 6 is 3 times 2. 4 and 6 still have this 2 in common, but within the LCM, we want to get rid of all the possible common numbers. So we only want to count this 2 once. Otherwise, we would be double counting it. Does that make sense to everyone? Does that make sense?
No.
No? Okay, up until what part did it make sense for you? Okay. Let me try this a different way. Okay, so let's start with like what LCM is. So the LCM of a group of numbers is basically all like the factors in common times the unique one. So if we're looking at, let's say, 6 and 3, the LCM of 6 and 3 will be the unique numbers times the common number. So the common number here is going to be 3, but the unique number for this is going to be 2, right? Does that make sense? So you basically
Yeah.
take 2, and then 6 when you divide by 3 is left by 2. But there's no more common numbers, 2 and 1. So the answer is just going to be 3 times 2, which equals 6. So now let's go back to looking at this. If we have 4, 5, and 6, there is still an overcount of like common factors because 4 and 6 both have, yeah? So 4 and 6 both have 2's still. So whenever we do the LCM, it's going to be 3 times 2 times 2 times 5 times 2 times 3. We still have this pair of 2's that are common, but we only want to count common numbers once, right? So instead of having these two happen twice, we only want it to happen once. So it should look like 3 times 2 times 2 times 5 times 3. This should be what our LCM looks like. Does that sort of make sense? Basically, whenever you at the LCM, if you look at any pair of numbers and there's still something you can take out, you want to take it out, even though you can't take it out of one of the numbers. So if I'm looking at the pairs, I see 4 and 5.
Okay, madam, please, I'm still not quite. Madam, please,
Okay, I'll try and approach it a different way, I guess. So when we have this set of numbers that we can't find any common number between the 3 of them, we should split it up into pairs. So instead of looking at all 3 together, let's look at 4 and 5 as one pair, 5 and 6 as another pair, and 4 and 6 as another pair. Okay? Yes. Whoever is raising the hand. Hello? Oh, okay. So if we're looking at 4 and 5, can we pull out any other factor from 4 and 5? No, right? So this
No.
one,
Only one.
yeah. Okay, let's look at 5 and 6 now. Can we pull out anything?
No.
Yeah. No, it's just 1. Now let's look at 4 and 6. Can we pull out anything?
Yes. 2.
Yes.
Pull out a 2.
Yeah, 2.
2.
Okay. So now when we look at this, we can still pull out a 2 from 4 and from 6, but we can just leave 5 alone. So when we pull out a 2 from 4, we're left with 2, and then we just leave 5 alone. And then we pull out a 2 from 6, which gives us 3. But when you do this, you have to be careful, because the GCF is something that's common between every. But this 2 is not common between all the numbers, so it cannot be included within the GCF, but it is still included within the LCM. Does that make sense to everyone a little bit?
Yes, please.
Yeah? Okay, cool. So we'll move on. But just be careful. When you come across a problem that looks like this, make sure you're not including 2, because 2 is not common between all the numbers. Only 3 is. So GCF should only be the numbers that are common within all of the numbers that you're looking for, like looking for the GCF one.
Anna is the LCM. For all the numbers.
Thank you.
Okay, cool. So let's move on. Let's do some more practice problems. So this is going back to sort of PEMDAS. So I'll let you guys try this one out, and then just like private message me the answer. Does everyone understand what they're supposed to do? Just like, I guess just solve the problem using PEMDAS and then just let me know the answer you get.
Okay.
Yeah, we'll go over the answer relatively quickly because the class is almost over and I just kind of want to go over what you have for homework. So. Okay. I'm just gonna go over the answer right now. I'll definitely post these slides, and there are a couple more practice problems that you guys can go through as well if you want more, I guess, practice. So the first thing you will do is that you will divide 24 by 8 because when we're looking at PEMDAS, if we look at PEMDAS, we see that division and multiplication come before addition and subtraction, which are like kind of the only components in this expression. So we're going to do the division first. Then we're going to multiply the answer of the division, which is 3, by 4. So this will be our second step. So we get 12. Then we're going to do 7 minus 12, which will give us 5. Or sorry, negative 5, and then plus 6, which will give us 1. Does that make sense to everyone? Make sure that when you are dealing with these type of questions, you are always moving left to right with addition and subtraction. Because I know if you moved from right to left, you would have gotten a different answer, because you would have gotten 7 minus, actually, I think you would have gotten the same answer. You would have, if you move from right to left, you would have gotten 7 minus 6, which would also give you 1. So it doesn't matter which way you kind of do the addition or the subtraction. Just make sure you do the multiplication and division before you do the addition and subtraction. Does that make sense to everyone?
Yeah.
Okay, so I'm just gonna quickly go over the homework now.
Yes,
So,
please.
so homework for this week, I will post 50 problems on a worksheet in Google Classroom. And you can definitely work out these problems on paper. Just make sure when you submit it, you can like submit all of them together if possible. If not possible, that's okay. Just yeah, just make sure you try and do the problems on the worksheet I give you on Google Classroom, and then just upload it. Ignore the due night before. Sorry, I think I put the wrong date. But try to get it in by Friday, or sorry, like the day before today. So that way I have time to go over it. But yeah.
Okay.
Thank you to those who submitted.
Okay.
Thank you to those that submitted the homework last week. I looked through most of them, and you guys are doing pretty well with it. So, yeah. I left you all some feedback, and the challenge problems have solutions in the slide deck I posted last week. But if you have any questions about those, just please let me know as well, and I can help explain it to you guys. So, yeah. Are there any other questions? Or
No.
no? Everyone's good? Okay.
So,
Okay, I guess that's all for today.
Thank you.
Yeah. Okay.
Give it.
Bye, everyone.
Bye.
Hello, Ms. Eno, can you please end the meeting? We can't end it from our own end, please. Can you end the meeting? The class is over.
Sure, I will. All right. I will.